Logic is an essential tool in philosophy, underpinning the entire process of reasoning. It is through logic that we assess the strength of arguments, ensure consistency in our beliefs, and ultimately seek truth. In this section, we will explore the key concepts of consistency, validity, soundness, and the role of logic in reasoning, highlighting their importance in philosophical inquiry. Consistency. Consistency is a fundamental aspect of logical thinking, requiring that our beliefs and statements do not contradict each other. In philosophy, maintaining consistency is crucial because contradictions undermine the coherence of any argument or system of thought. For example, consider the following set of beliefs: A is taller than B is taller than C, and C is taller than A. This set is inconsistent because it leads to a contradiction. If A is taller than B and B is taller than C, then it cannot be the case that C is taller than A. Another example of inconsistency might involve beliefs about time. John arrived at the party before Mary, Mary arrived before Sarah, and Sarah arrived before John. If all these statements were true, they would create a circular and contradictory timeline. A final example could involve moral beliefs. Lying is always wrong, it is wrong to cause unnecessary harm, and it is okay to lie if it prevents harm. This set is inconsistent because the third belief directly contradicts the absolute stance of the first belief. These examples illustrate how inconsistent beliefs cannot all be true simultaneously, signaling a flaw in the reasoning process. By striving for consistency, philosophers ensure that their arguments are internally coherent and reliable, forming a solid foundation for further inquiry. Validity. Logical validity is a multifaceted concept, encompassing both the idea of logical consequence, what follows from what, and the impossibility of the conclusion being false if the premises are true. These two aspects are deeply interconnected and central to understanding what makes an argument valid. The first aspect of validity emphasizes the tight connection between the premises and the conclusion. It focuses on the logical consequence, where the conclusion follows necessarily from the premises. This relationship highlights the support the premises provide to the conclusion. For example, consider the following argument. 1. 5 is a prime number. 2. Therefore, 5 is divisible by 1 without remainder. Here, the conclusion follows from the premises because they are connected through the concept of prime. This logical connection ensures that the premises provide strong support for the conclusion. The second aspect of validity emphasizes how tight this connection is, making it impossible for the conclusion to be false if the premises are true. In the above example, the connection between the premises and the conclusion is so tight that if the premise is true, the conclusion must also be true. The concept of prime guarantees that any number that meets the conditions outlined in the premise will also meet the conditions stated in the conclusion. These two aspects of validity, the logical consequence and the impossibility of the conclusion being false, are closely related. The logical connection between the premises and the conclusion not only dictates that the conclusion follows, but also ensures that this conclusion is necessarily true whenever the premises are true. Understanding these facets of validity is essential for evaluating the strength and soundness of arguments in philosophy. Philosophers and mathematicians have generalized these insights and uncovered general argument schemas or forms that ensure validity. One example of a valid form is modus tollens. 1. If P, then Q. 2. Not Q. 3. Therefore, not P. In this form, if the premises are true, the conclusion necessarily follows. For example, 1. If it is raining, then the ground is wet. 2. The ground is not wet. 3. Therefore, it is not raining. Another example of a valid form is modus ponens. 1. If P, then Q. 2. P. 3. Therefore, Q. For example, 1. If it is a bird, then it has wings. 2. It is a bird. 3. Therefore, it has wings. Validity can hold for tightly connected by discernible reasons. Syntax, the structure or form of statements, can determine validity. For instance, an and statement is true just in case both statements flanking the and are true. For example, it is raining and it is cold is true only if both it is raining and it is cold are true. Meaning. The meaning of certain expressions can guarantee validity. For instance, the meaning of blue all over implies that if X is blue all over, then it has no red spots. This is true because the concept of being blue all over logically excludes the possibility of having any other color. Understanding these different bases for validity helps philosophers and logicians evaluate arguments more precisely, ensuring that their conclusions follow logically and rigorously from their premises. Unusual results of validity, truth and falsehood no matter what. Logical validity, while a robust and essential concept, can sometimes lead to results that seem unusual or counterintuitive, though they remain harmless in the context of logical reasoning. These unusual cases occur when arguments are valid despite the premises and conclusion not appearing to be connected in a relevant or meaningful way. One such case involves arguments with conclusions that are true no matter what, often referred to as tautologies. For example, consider the following argument. 1. The moon is made of cheese. 2. Therefore, 2 plus 2 is equal to 4. This argument is technically valid because the conclusion, 2 plus 2 is equal to 4, is a mathematical truth that holds regardless of the truth of the premise. In logical terms, it's impossible for the conclusion to be false when the premises are true, simply because the conclusion is always true. However, the premise and conclusion seem entirely unrelated, illustrating one of the unusual but harmless results of validity. Another example involves arguments where at least one premise is false no matter what. Consider the following. 1. 2 plus 2 is equal to 5. 2. Therefore, the earth is round. This argument is also valid because the premise, 2 plus 2 is equal to 5, is always false, making it impossible for the premises to be true in the first place. The rule of validity states that if the premises were true, the conclusion must also be true. But since the premise is false, the condition of having true premises is never met, and the argument is considered valid by default. Again, despite the lack of a relevant connection between the premise and the conclusion, the argument is valid. These examples highlight an important aspect of logical validity. Validity is concerned with the structural relationship between premises and conclusion rather than their actual content or relevance. As long as it is impossible for the conclusion to be false when the premises are true, the argument is valid, even if the premises and conclusion seem disconnected or nonsensical. This illustrates that while validity is a powerful tool in ensuring sound reasoning, it operates within its own specific logical parameters, which sometimes lead to unusual but logically consistent outcomes. Unusual results of validity, inconsistency. Another unusual aspect of logical validity relates to the connection between validity and consistency. Specifically, an argument with an inconsistent set of premises is always considered valid. This might seem counterintuitive at first, but it follows from the definition of validity. If it is impossible for all the premises to be true and the conclusion false, then the argument is valid. In the case of inconsistent premises, it is impossible for all the premises to be true simultaneously, so it's trivially true that the conclusion cannot be false when the premises are true, because the premises can never all be true together. For example, consider the following argument. 1. All dogs are cats. 2. No cats are animals. 3. Therefore, the earth is flat. This argument is valid, despite the premises being inconsistent and the conclusion unrelated to them. The premises all dogs are cats and no cats are animals are both false and mutually contradictory, making it impossible for both to be true at the same time. Since there is no situation in which the premises are all true, it is impossible for the premises to be true and the conclusion to be false. Therefore, by the definition of logical validity, this argument is valid, even though the premises and conclusion are disconnected and nonsensical. This aspect of validity underscores the importance of consistency in logical reasoning. While an argument with inconsistent premises is technically valid, it fails to provide meaningful or reliable conclusions. This reinforces that logical validity, while a crucial standard, must be paired with consistency and soundness to ensure that arguments are not just formally correct but also practically useful and informative. The ancient and modern contributions of Aristotle, John Venn, and Augustus de Morgan. The concept of validity has been shaped and refined by several key figures in the history of logic, each contributing to our understanding of what it means for an argument to be valid. Aristotle, often regarded as the father of logic, laid the groundwork for the study of logical validity in his Organon. He introduced the syllogism, a form of reasoning in which a conclusion is inferred from two premises. Aristotle's exploration of syllogistic reasoning was the first systematic attempt to formalize logical arguments, establishing the idea that validity is determined by the structure of the argument rather than the content of the premises. His work on syllogisms set the stage for future developments in logical theory, emphasizing the importance of the relationship between premises and conclusions. In the 19th century, John Venn made significant contributions to the study of validity through his development of the Venn diagram, a tool that visually represents logical relationships. Venn diagrams allow us to see how the premises of an argument relate to one another and to the conclusion, making the concept of logical consequence more intuitive. By mapping out different possibilities and showing how they overlap or exclude each other, Venn diagrams help clarify when an argument is valid by ensuring that the conclusion must follow from the premises. Venn's work provided a powerful visual method for understanding logical validity, particularly in the context of categorical logic. Around the same time, Augustus de Morgan made crucial advancements in formal logic, particularly through his formulation of de Morgan's laws. These laws describe the relationships between logical operators like and, or, and not, and they are essential for understanding the validity of complex logical expressions. De Morgan's laws reveal how the negation of conjunctions and disjunctions operates, furthering our grasp of how premises interact to support or undermine conclusions. His work on formal logic and the rules governing logical operators contributed to a more precise understanding of validity, especially in cases involving compound statements. Together, the contributions of Aristotle, Venn, and de Morgan have enriched our understanding of logical validity, providing both the foundational principles and the tools to analyze and evaluate arguments rigorously. Their insights continue to inform contemporary discussions of logic, reinforcing the importance of validity in philosophical reasoning. The modern contributions of Bertrand Russell, Alfred North Whitehead, and Gottlob Frege. Bertrand Russell and Alfred North Whitehead made monumental contributions to the study of logic and validity through their collaborative work, Principia Mathematica. This seminal work aimed to ground all of mathematics in logical principles, demonstrating that mathematical truths could be derived from logical axioms through a formal system. In doing so, Russell and Whitehead developed a highly rigorous framework that sought to eliminate ambiguity in mathematical reasoning, thereby reinforcing the concept of logical validity. Their work introduced the idea that logic could serve as the foundation for all mathematical truths, leading to the development of symbolic logic, which has become a cornerstone of modern logic. Principia Mathematica also addressed paradoxes in logic and set theory, such as Russell's paradox, further refining our understanding of validity by exploring the limits of logical systems. Gottlob Frege, often regarded as the father of modern logic, made equally profound contributions to the field. His work laid the groundwork for the formalization of logic as we understand it today. Frege introduced the concept of quantifiers and variables, which allowed for a more precise expression of logical relations and the development of predicate logic. His Begriffsschrift was the first formal system that represented logical relationships using a fully developed notation system. Frege's work emphasized the importance of logical form and the rigorous analysis of language and meaning, which are crucial for understanding logical validity. His distinction between sense and reference, Sinn and Bedeutung, in language further deepened the philosophical understanding of how statements can be valid, depending on how they refer to objects and concepts in the world. Freya's ideas influenced not only Russell and Whitehead but also the entire trajectory of 20th century philosophy and logic. Together, the contributions of Russell, Whitehead, and Freya have shaped the modern landscape of logic. They have provided the tools and frameworks that allow for the precise analysis of validity, enabling philosophers and mathematicians to explore the foundations of truth, consistency, and reasoning in a formal and systematic way. Their work continues to influence contemporary studies in logic, mathematics, computer science, and the philosophy of language. The limitations of logic. While logic is an indispensable tool in philosophy and reasoning, it is important to recognize its limitations. One key limitation is that logic, particularly logical validity, is better understood as providing norms or standards for reasoning rather than a description of how we actually reason in everyday life. Logic offers a framework for how we should think if we are to reason correctly, but empirical research suggests that our actual reasoning processes often diverge significantly from these standards. Research in the bias and heuristics literature, pioneered by psychologists such as Daniel Kahneman and Amos Tversky, has revealed that we rarely follow strict logical rules when we reason. Instead, we tend to rely on a grab bag of heuristics or rules of thumb, mental shortcuts that allow us to make decisions quickly and with minimal cognitive effort. These heuristics are useful in many situations, but they can also lead to systematic errors or biases, demonstrating the gap between ideal logical reasoning and our everyday thought processes. A classic example illustrating this gap is the bat and ball problem. Problem: a bat and a ball together cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? Intuitive, but incorrect, answer. Most people quickly respond that the ball costs 10 cents, which would make the bat cost $1.10, adding up to $1.20, not $1.10. Correct, but less intuitive, answer. The ball actually costs 5 cents, and the bat costs $1.05, which together total $1.10. This example shows how people often use a heuristic to arrive at an answer quickly, rather than applying logical reasoning to work out the correct solution. Another well-known example is the Linda is a bank teller problem, which demonstrates the conjunction fallacy. Problem: Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which is more probable? 1. Linda is a bank teller. 2. Linda is a bank teller and is active in the feminist movement. Intuitive, but incorrect, answer. Many people incorrectly choose option 2, thinking it is more probable based on Linda's description. However, this violates a basic rule of probability and logic. The probability of two events occurring together, conjunction, is always less than or equal to the probability of one of the events occurring alone. In these cases, our natural reasoning processes rely on heuristics rather than logical rules, leading to errors that logical reasoning would avoid. These examples highlight the limitations of logic when it comes to describing how we actually think. Logic provides a normative ideal, standards for how we ought to reason to avoid these kinds of mistakes. However, understanding the limitations of logic helps us appreciate the complexity of human reasoning and the importance of combining logical analysis with insights from psychology to fully grasp how we think and make decisions in real life.